Okay, can you hear me?
Hello, hello.
Can or not? Can you hear me?
Can.
Okay, right. So let me see your expansion. 6C, how to rotate? Cannot rotate. Never mind. I just read like that. Oh, you didn't change the positive negative sign because there's a negative there. You have to change the positive negative positive negative. The other 61 is 6, 62 is 6 times 5, 15, correct? 15, 63 is 5 times 4, 20, correct? All correct, except the sign. Okay, right. Let me see. Okay. coming back to this, so I show you the sign, right? Okay, this one. Why I didn't? Okay, right. Now, you can hear me, right? So your expansion is correct, except that you see the negative y to the power of 3. So there should be a negative sign here, right? Here, sorry. Here. Then negative y to the power of 5. There should be a negative sign there. So other than that, everything is correct, right? Everything is correct. So remember, if you encounter a negative sign, please make sure that it will be negative, positive, negative, positive. Okay, right. Now we go back to the trend, the trend. Yeah, not this one. This one. Okay. Now we not this one. Okay, here. This one, right? Okay. Okay, right. Now this is what I told you earlier. This is what I told you earlier. That in general, there is this binomial expansion. The trend is like this, right? Negative NC0, NC1, NC2, NC3. Now, once you know this is 0, you know the B is power 0, A is power n. Then this one, NC1, this one decreased by 1, this one is 1. NC2 decreased by 2, then this is 2. So that the total power is actually equal to n. Okay, then something that you need to note here is if you have a plus b to the power n, then there will be n plus 1 terms. Let's say if there's a plus b to the power of 6, then there will be 7 terms. A plus b to the power of 10, then there will be 11 terms. So this is the first thing that you need to know. Now, the second thing you need to note is that the first term is NC0. Let's say 4C0, b to the power of 0, then a will be to the power of 4. The last term is 4C4, 1. Then a to the power of 0, then b to the power of 4. So there is a relationship between the two powers. If you give you 1, you will know the other power. How? You use n minus the one that you know, you will get the power that is unknown, that you don't know. Okay. But the relationship between the number NC something, that one is related to B. It's not related to A. Okay. So in order to get A, then you use n minus the B, the power B, then you get power A. Okay. Now, I'm telling you all this, but I don't know, without numerical examples, surely you don't know what I'm talking about, right? So what I want to talk about is this one, right? Right. You want to predict. Okay. Let's say we come back to a plus b to the power 6. So the first term will be 6. This one will be 6 minus
0.
6 minus 6, then you will get 0, right? This is 5. 5 plus 1 will be 6. Let's say if I give you 5, you use 6 minus 5, then you will get 1. If I give you 1, then you take 6 minus 1, then you will get 5. Is that okay? You must know how to predict the power of any one of the terms. If they give you 1, you must know the other one. Okay, right. So if you know the pattern like this, then we look at one example. Find the third term and the sixth term in the expansion. This one, this one. a plus b to the power of 6. A plus b to the power of 6, they are all together 7 terms. And I want to know what is the third term. Now, the third term, is which one? 1, 2, 3. This should be the third term. But without looking at what I have shown you here, without looking, do you know how to get the third term? The third term will be the b is to the power of 2. Why I say the third term is b to the power of 2? The first term is b to the power of what? Can you tell me?
0.
0. So b to the power 0, b to the power 1, b to the power of 2. So the third term is actually b to the power of 2. Since you know b is raised to the power of 2, what is the power of a?
4.
4. How to get 4? 6 minus 2, you get 4. Now, let's say if the b is raised to the power of 2, b to the power of 2, the number in front is how many? C, how many?
6. C2.
Very good, 6C2, because the bottom one always follow the b. So it's 6C2. Why? Because this one is 6, because they are raised to power 6, so 6C2, very good. So that is how we predict the term. That is what I mean by predict a general term in the expansion. They won't tell you which term they want. You have to tell them the whole term. They tell you one thing about the term, then you must know everything about the term, right? So now we want to predict the sixth term in the expansion. Sixth term means what, you know? 61, 62, 68. Now 6, the power is 6 altogether, 7 term. So the sixth term will be the second last one. The second last one. So sixth term, what do you think is the power of b? Sixth term. What is the power of b?
6.
Altogether 7.
5.
5, the sixth term until here. The sixth term. 6C0, 61, 62, 63, 64, 65. Right? So it's b to the power of 5, right? b is raised to the power of 5. Then how to get the power of a? 6 minus 5. 6 minus 5, right? So a 6 minus 5 is 1, no? So you have a to the power 1, b to the power 5. What is the number in front? We know the b is 5. The b is 5, right? This number in front is how many? C, how many?
65.
6C5.
65.
Okay, 65. So this is correct. Right? This is correct. Okay, right. So this is it. Right? Now, instead of telling you the term, which term they want, fourth term, fifth term, sixth term, instead of telling you the term they want, they may tell you, oh, actually, I want the term. I want the term. Okay. They say, I want the term with a to the power of 2. Do you know which term is a to the power of 2 or not? Don't know, right? How to predict the others, then come back to you. Then they say, I want the term with b to the power 3. How many terms are there in these 7 terms? How many of them has b to the power 3? Only one. Only one. All the 7 terms, only one of them with the power of 3. And I'm going to predict the whole term that has b to the power 3. Do you understand what we want to do now?
Yes.
Yes, they will give you one piece of information. Then they want all the other information about that particular term. That is what they want. Right? So we start with the first part. Find the term with a squared. A squared. So now I write down, if a squared, what will be b? What will be our b? B to the power what?
4.
B to the power 4. How to get b to the power 4? We take that particular number, the n, which is 6. 6 minus this one. Then I know b is to the power 4. Now, if b is to the power 4, the coefficient always follow b. The coefficient won't follow a1. Won't follow a. Okay, so if it's b to the power 4, what is the coefficient? How many c? How many?
64.
Correct, 64, because they always follow the b. So 64, you have found out that 64 is 15. So 15, a is a squared, b is b to the power 4. That's how we predict the whole term without actually expanding out all the 7 terms. Okay or not? Can follow? Yes. Now I want to predict the term with b to the power 3. Very easy, lah. If b to the power 3, what is the power of a?
3.
3. What is the coefficient?
63.
63. So I combine all these 3 together. That will be the term with b to the power 3. So it's 20 a cubed b cubed, right? Okay. Now I want to ask you, can you look at your lecture notes? This one, this is your lecture notes.
No.
This is your lecture notes. And they say this expansion, a plus b to the power of 11. Okay, a plus b to the power 11, but they want to predict the 5th term. Okay, so if you have forgotten, then afterwards I'm going to load this video in the YouTube. Then you look again at the YouTube. Then can you do all these 3 questions and pass up to me?
Yes.
Okay, so I'm not going through this. I will take your answer. I go through your answer the next lesson. Okay, right. So we go on to a new topic. This cannot move on. My picture is blocking. Can move a little. Okay, right. Okay, so now we're going to do something. Okay, right. Okay, right. So we are going to look at a sequence. Then this particular sequence that we're going to study today is called the arithmetic sequence or the arithmetic progression, right? Now, actually, there are many types of sequence. I look through your syllabus, only 3 types that you learn. 3 types of sequence that you learn. So I'm going to go through each of the 3 types of sequence for you, right? Okay, so we're going to look at the first sequence. Okay, right. Now this, there are 3 sequences here. There are 3 sequences. 1, 4, 7, 10. This is one type of sequence. Now, why we call it the sequence? Because by looking at the pattern, right? 1, 4, 7, 10, I can actually predict what is the next term in this sequence. These are called terms. first term, second term, third term, fourth term, like what we see in the binomial expansion. Yeah, terms. But this one, since I put dot, dot, dot there, there are many, many terms, infinite number of terms, or some people say infinite number of terms. That means the terms are never end one. You can go on and on and on, right? No end. Okay, so this is another type of sequence. This is another type of sequence. 2, 6, 18, 54, and so on. And there are many, 1, 4, 9, 16, and so on. So these are the three types of sequence that you're going to learn in your lecture, right? These are three types. Okay, now what we want to study is how they form this type of sequence, how they form it, predict the next number in the sequence, add up all the numbers in the sequence, which is called a series. So when you want to add up all the numbers, they are called a series. So sum of the series, they say sum means add up. Sum of the series means add up all the numbers. So these are the things that we want to learn to predict the term, like what we have predicted earlier, and also to find the sum of the sequence, which is called sum of series. Okay, so next thing. Can you predict what is the next number here? 1, 4, 7, 10, then next one?
13.
13. Correct, huh? It's 13. It's 13. Then this one? 2, 6, 18, 54.
162.
Okay. So this one, 1, 4, 9, 16. What is the next number? One is actually 1 square. You know square? Power of 2. This one is actually 2 square. This one is what? How many square?
3 square.
3 square. This one?
4 square.
What is the next number here?
5 square.
5 square is how much?
5.
How much is it?
25.
Ah, correct, 25. Okay. So why they go back one or okay. So now how to get the next number? You add 3 there. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. So this is what you told me just now, right? But how to get this number 3? How I know is add 3, add 3. What you can do is you take the number behind minus the number in front. 4 minus 1, 2. 7 minus 4, 3. 10 minus 7, 3. So that's how we get the number 3, right? Next one. Okay. So this one, 2, 6, 18, 54. How to get? From 2 to 6, you multiply by 3. 6 multiplied by 3, 18. 18 multiplied by 3, 54. So the next number, you take 54 multiplied by 3, okay? So we see 54 multiplied by 3. Answer is 162. 162, right? So the next number is 162. Okay, right. So how do I know I must multiply by 3? How to get the number 3 there? Can you guess? Teka-teka lah, cannot naman. Can you guess?
No.
Huh? How to get the number multiplied by 3, multiplied by 3? How to get the number 3?
That's not.
So in order to get the number 3, you take this 6 divided by 2. 6 divided by 2 is what?
3.
3. 18 divided by 6.
3.
54 divided by 18.
3.
So that's how we get the number 3. You take the number behind, divide by number in front, then you get, right? Okay, right. Next one. So you just square the number, you get it. So these are the 3 things that you're going to learn in your lecture. But I'm going to show you the first type first, because there are a lot of things to talk. One type, I have to tell you many things, right? Okay. Okay. So now I want to ask you this one. 2, 5, 8, 11, 14. This is a sequence. Now this sequence belongs to which type? First, second, or third?
First.
First type is by adding on. Second type is by multiplying. Third type is by squaring. So this one is what type is this? How to go from 2 to 5? Square.
Adding 3.
Add how much?
3.
3. How to get 3? You take 5 minus 2, you get
Minus
3.
2.
8 minus 5, you get 3. So that's how we get this, right? So we keep on adding 3, but how to get the number 3? You subtract, you do the reverse, then you know how to get the number 3, right? And this type, where you get the number by adding, is called arithmetic progression or arithmetic sequence. So today we are going to do arithmetic progression or arithmetic sequence only. The other 2 later on. Okay, the other 2 later on. This one, how to get? Which type? This one. 3, 6, 12, 24. The first type, the second type, or the third type?
Second type.
Yeah, correct, the second type. What is the number that you proceed from one term to another?
Multiplying by 2.
Sorry?
Multiplying by 2.
You multiply by 2, right? 3 multiplied by 2 is 6, 6 multiplied by 2, 12, 12 multiplied by 2 is 24. How to get the number 2?
6 divide 3.
You take the number behind, 6 divided by 3. That's how you get the 2. And this type of sequence is called geometric progression. The type that you multiply one is called geometric progression, right? Geometric. One is arithmetic, one is geometric. And this one, 2, 8, 18, 32. So we also square. But the square, then you multiply by 2, right? 1 square multiplied by 2 is 2. 2 square multiplied by 2 is 8. 3 square multiplied by 2 is 18. So this one is also the square type, right? This is the square type. Okay. So we are going to concentrate on this type of sequence. Can you tell me what sequence is this? Arithmetic or geometric?
Arithmetic.
Arithmetic. This one is arithmetic. How to get the number? What is the number that we proceed from one term to another?
Adding 5.
Add 5. The number 5. How you get the number 5? 7 minus 2, 5. 12 minus 7, 5. So, okay. Why like that? Okay. Right. So we try to find the number. 7 minus 2, 5. 12 minus 2, 5. 17 minus 12, 5. 22 minus 17 is also 5. So make sure that every number is 5. If one number is not 5, then it is not a arithmetic progression, right?
Mm.
Okay. So this number 2 is called the first term. First term. And we give the first term a symbol. The symbol is A. The symbol is A. Then this number 7, this number here 7, is called the second term. And the symbol is T2. T with a small 2 at the bottom, subscript 2. So similarly, we can call the first term T1. T1, T2, T3, T4. They are the first term, second term, third term, and fourth term. And especially for the first term, we give it another special symbol called A. So the first term has two types of symbol, no? TA or T1. So both of them, they are the first term. Right?
Mm.
And the number that you told me just now, 5, is called the common difference. That number 5 is called the common difference. How to get the common difference? You take the number behind, subtract the number in front. For example, I take 22 minus 17. They must be next to each other. You don't take a gap like that, then you take the number behind, minus one number very far in front, then it's not like that, right? So the two number must be next to each other. If you take 17 minus 7, cannot. It must be two next to each other. These two numbers next to each other, they are called consecutive terms. Consecutive terms. They are called two consecutive terms. Okay, there's a name for them. The two that is next to each other is called two consecutive terms. Right? So if you take two consecutive terms like this, n and n minus 1, they are two consecutive terms, and you minus the one behind minus the one front. Cannot take the front minus behind, cannot. Must take the behind minus the front. And that number will be our common difference. Different arithmetic progression, they have different common difference, right? Okay, so there are many terms that you need to know, okay? The terms that you need to know, they are, one cannot move away, okay. So the terms that you need to know, right? In general, for any arithmetic sequence, you must know the first term and also what is the symbol for the first term. So first term, the symbol is T1, its symbol is also A, right? A. So where is it? This one. This one is A, right? Then the common difference is D, right? The symbol that we use for common difference is D. The term number, we call it N. Then the nth term is, we have 10 minutes left, right? We have 10 minutes left. Now the nth term can be any term there. Because we don't know what is the number, the term number, let's say 22. I don't know what number is it. Of course, here I know it's T5 lah. Let's say if I don't know what number is it, I call it Tn. If you know the number, then you call it T5 lah. If you don't know, then you call it Tn. That's where the term Tn come from. Then the last term, we call it L. Here got how many terms? Got 5 terms. First term, this one is called A. Oh, this is the last one. We call it L. So that's how we get the last term. Then Sn pula. Sn is the sum of first n terms. That means you add up all these numbers, they are called Sn. If you know there are 5 terms, then they call it S5. You want to add all the 10 terms together, you call it S10. Okay. Next, we are going to look at the formula. These are the formulas involved, okay? D is Tn minus 1. Then Tn is equals, the formula is A plus n minus 1D. Sn is equal to n over 2a plus L. Sn equal to n over 2a plus n minus 1D. Now, this formula, you don't have to worry. As we proceed, I'm going to show you what is the meaning of this number, how to make use of this formula. Right? No need to worry. I just tell you there are altogether 4 formulas for this arithmetic progression or arithmetic sequence, and you must remember what are the terms, what are these things, because in the exam or in the test or what, they just tell you first term, common difference, term number, or sum of first term. You have to know what is the meaning of it. So you must know the meaning. How to use the formula later on, I will show you, right? Later on, I will show you. Okay. Next, we are going to look at this. This one. Pop. Come out. Pop. Come out. Okay. Now, let us now consider a finite series. Now, just now, I tell you infinite means the series, sorry, the term, sorry, the sequence has no end. That one is infinite, infinite. But this one, the term is finite. That means we actually know how many terms are there. We actually know how many terms. So let's say 3, 5, 7. Oh, they give you the last number. Now, if they give you the last number, that's it. These are the terms. You cannot extend beyond 87. So 87 is the last term, right? If you see the dot, dot, dot there, like this, dot, dot, dot like that, that means there are many terms to follow, right? If you see like that, dot, 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 then stop there, 87, that means it's finite. They will just stop there. Beyond this, no more already. So using this sequence, can you tell me this one, 3, 5, 7, 87. Can you tell me what is the first term? T1 or the A? This one. Can you tell me?
3.
3. Then can you tell me the common difference? Common difference. Can you tell me this?
2.
2. Very good. 2. So you take the behind minus the front one, but it makes sure that they are 2 consecutive terms. Take behind minus 2. Very good. Okay. Then can you tell me what is the this one? Don't know the term number. Okay. Can you tell me what is the last term? Last term. Last one.
87.
Yeah, correct. 87. Then the sum of first n terms. Sum of first n term means you add like that. 3 plus 5 plus 7 plus 5. I don't know how many are there. Then, you add until 87. That is the sum of all the terms. That's why the symbol is Sn. Anyway, we don't know how many terms are there. 87 is the number what now? Number 10 term. 87 is the number 20 term. I don't know. I don't know. Right? I don't know what number. I know the number, but I know what term is it. Which term is it? I don't know which term. So if you don't know which term, then you call it En. And there is a way to find out the n. We can make use of the formula and find out, then we know, we know how many terms are there in this sequence. Okay? Okay, right. So now I show you the formula again, right? I show you the formula again. These are the formula that we are going to use to calculate. And we are going to look at the same sequence, or because this one is finite, so we call it this series, right? Okay, so go through. Okay, next one. This 3, 5, 7, is it an arithmetic sequence? Yes or no? How do you know? Huh? Then I check lor. I take 5 minus 3. I take 7 minus 5. If every number, the difference is the same, all the differences, they are the same value, I mean differences, same value, then we say it's an arithmetic progression, right? So I check. Oh, I take the T2 minus the T1 or 5 minus 3 or is 2. Okay, lor. Never mind. But I have to check behind T3 minus T2. This is T3. T3 minus T2 is what? 7 minus 5. Oh, also 2. So I know, oh, this is an arithmetic sequence or an arithmetic progression, right? Time is running out already. Okay, so now how to get the common difference? I take this number, the common difference D, but you must know the symbol is D. D equals to 2 and A equals to 3. Right. Time up already. So I tell you what. You look at these exercises here. What are the numbers that you can try? This one cannot. Cannot. You can only try number 1 or given each term. I try. Also cannot do yet. Oh, never mind. Then I have to tell you this formula. Okay. Now this formula here, this one, Dn equals to A plus n minus 1D. This is the formula. Right. Now, let's say T11, I want to find the 11th term. Okay, you see from the formula there, Tn, I replace the n with 11. The A, I replace with 3. The n, I replace with 11. The D, I replace with 2. As a result, I can straight away find out the 11th term is 23. 11th term. So this formula will enable you to find any number of terms that you want. Then, for example, here the last term, I don't know what number is it, then I call it Tn, right? So the Tn is 87, the A is 3, N I don't know, but D I know is 2. Solving the equation for the value of N, then I found out, oh, you know how to solve equation, right? So I found out, oh, N is 43, right? So now I know 87 is the 43 term. So with this, you can actually find out, you can actually do number 1, number 2, and number 3. Just do these 3, 1, 1, 2, and 3. And also the predict the term. So that's all, right? The time up already. So we stop here.